Okay, so the last thing we have to talk about is the idea of chemical reactions, which are represented by chemical equations. Now, all of these changes that we talked about, where one atom will combine with another atom and form either a covalent bond or an ionic bond, is basically a chemical reaction that's taking place. Whenever you form new compounds by putting atoms together, by either transferring or sharing of electrons, you form a chemical reaction. Now, a chemical reaction will have two basic components. You're going to have the reactants and the products. Now, the reactants will be the ones that started the chemical reaction or got together to do the things. And then the products will be the ones that you got out of the chemical reaction. So, reactants before the arrow, products after the arrow. The arrow means use or builds the actual reactants. So it shows the direction in which the reaction is taking place. Now, sometimes you will see arrows going both ways. You see that over here? That means the reaction is in equilibrium and that it's going this way just as much as it's going the other way. Okay? And sometimes you have an arrow that looks more like that than like this, and it's saying that the reaction is happening more this way than it's happening that way. And that's kind of the concept of chemical reactions. Now, sometimes you also see things like special symbols. For example, plus signs it means you basically adding the reactants together or adding the different products together. The arrow means reacts to form or yield. A little S next to the word means it's a solid. An L means it's a liquid. A G means it's a gas. AQ means this is happening within an aqueous solution. If you put a little triangle on top of the arrow, it means that you need to add heat to make this happen. And if you make a PT on top of the arrow or bottom of the arrow, it means that you need to use an enzyme or a catalyst to actually make this happen. In the example, a PT means that platinum was used as the catalyst. So whatever little element that you put on the arrow means that that was the catalyst that was used in the reaction. And sometimes you also see arrows pointing downwards next to something, like let's say you had like NaCl and then an arrow pointing downwards. That means precipitate will form, and that means that something will come out of the solution and fall to the bottom. Alright? And the opposite is true. If you get an arrow pointing upwards, it means it's going to float up, and sometimes even become, if it's a gas at the same time, it will bubble out of the solution. Alright? So these are examples of symbols that will show up sometimes in chemical reactions. Now, an interesting thing about chemical reactions is that, remember, this is going to be a change on the composition of the matter. So, for example, look how we have glucose on one side, and then that glucose gets broken down into carbon dioxide and water in the presence of oxygen. And that the opposite of this chemical reaction is photosynthesis, where exactly the opposite takes place. So see, chemical reactions are reversible. But what's key about them is that the atoms are switching places. The atoms are moving around. Alright? But notice that as the reaction takes place, you're actually going to conserve energy in this reaction. And you're going to conserve mass as well. Now, energy might be released during the reaction. For example, during photosynthesis, you have to absorb energy. But that means the environment lost it. And during cell respiration, you release energy. But that means that the chemical compounds lost it. And then the matter is going to be conserved as well. It means whatever you had at the beginning, you have at the end. Which is why you have to balance the equation so that the correct number of atoms are always represented. And you're going to use that by doing coefficients and the subscripts. Remember, subscripts means how many of those atoms are within that molecule. So that means that in glucose, I have 6 carbons, 12 hydrogens, and 6 oxygens. But in this formula, I have only 1 glucose, but I have 6 oxygen gases, each with 2 oxygens in it. So you see how that works out, right? Now, remember that these are two complementary reactions, cell respiration and photosynthesis. Cell respiration is going to be making energy for life, and photosynthesis is going to be the one that's going to be storing the energy from sunlight into the sugar, which is going to be then consumed by animals and plants and going to be burned when needed for energy purposes. Now, there's actually very many types of chemical reactions, and although I don't expect you to know this in detail for the purpose of aerospace science, you need to know that reactions can be either redox or non-redox reactions. And redox reactions are reactions where energy is transferred through electron transfers. In chemical reactions, can also be combinations of putting two atoms into larger atoms. It's called a combination reaction. And you'll see an example of a combination reaction right here, where iron and oxygen gas are combining to rust the iron into iron dioxide. This is also called a synthesis reaction. The opposite is a decomposition reaction, which breaks the particles apart. So you have something that actually gets broken into its constituent parts. And you have several examples here of decomposition reactions. See that over there. Alright? You also have reactions in which particles are exchanged or changed positions. And the most common examples are single or double replacement. So you see this one here is a single replacement where one atom switches places with another one within a compound. And the second one is a double replacement. So you see here an example of a replacement, and here in the square you see an example of a double replacement. And look at that, the arrow down. It means it's going to precipitate and fall out of the solution. Now you also have another special type of reaction. It's called combustion reaction. The combustion reaction is a special type of reaction where something combines with oxygen to burn to form carbon dioxide and water molecules. Alright? And that's basically how combustion actually looks like. Now, you also have another special type of reaction. It's called an acid-base reaction. When you get an acid combined with a base and you neutralize them to form salt and water. Okay? And a great example of this is when you get something, for example, like hydrogen chloride, and you combine with sodium hydroxide. Hydrogen chloride is an acid, sodium hydroxide is a base, and then you're going to have a double substitution reaction taking place here, or double displacement, and you're going to have the hydrogen combined with the OH to form water, and you're going to have the sodium combining with the chlorine to form salt. So you get salt plus water. See? Now, if this is going to actually neutralize each other, it depends on the strength of the acid, the strength of the base, and how much of each you actually have. So these are just the different kinds of chemical reactions and that will happen in nature. And remember, these are things which cause those atomic combinations that we talked about on the previous videos. So that finishes our topic about matter. And we learn about so many different things in this topic. We learn about the properties of matter. We learn about what matter is made of. We learn about elements and atoms. We learn about the fundamental forces, atomic numbers, atomic mass, atomic weight, allotropes, isotopes, radioactivity. We talked about half-lives and how to use radioactive isotopes. We talked about energy levels, electron shells, and what do they mean about the atom. We talked about valence electrons. We talked about the electron stability and electrical charge. We talked about how to make the Bohr models. We talked about periodic table patterns, including atomic numbers, the rows, the periods, the valence, the orbitals, the families, the sizes, electronegativity, metallic character, reactivity, the groups of the periodic table, the states of matter shown, the reactivity, the radioactivity, natural versus synthetic elements, and even the abundance of the elements on life. Then we talked about matter combinations. We talked about atoms getting together to form mixture, which is the physical combinations, which can be either homogeneous or heterogeneous. And that depends on the level of analysis. We talk about solutions and suspensions. We also talk about actual matter combinations to form things like chemical compounds or pure substances in chemical combinations. We're talking about how that changes the physical and chemical characteristics of the elements. And we also talk about molecules, which are the smallest unit of any of these substances, and the chemical formulas that are used to represent them. Then we talk about the different kinds of bonding, both intramolecular and intermolecular forces, including ionic, covalent, and metallic bonding and the relative strengths of those bonds. And then we talk about intermolecular forces, which include crystalline ionic forces, structures, and the van der Waals forces, which include things like hydrogen bonds and other types of dipole interactions. And then we finish with talking about chemical reactions, chemical equations, and how it all works out. I hope this all makes a lot of sense to you, and if you have any questions, make sure you write them down and come ready to ask them in class. Good luck, and don't do anything that wouldn't make your mama proud.